Right. Any other question here? Apart from this mean and median and mode. Okay, fine. We'll move on. Okay, measurement system analysis. Okay, see, as I told you in Six Sigma level, taking a data is a major challenge. Okay, so that they'll spend a lot of time on taking the data. That problem is not available for a healthcare, because whatever we are running the report, our system are capable enough to give you the report completely. Okay, that is the major advantage what we have in the healthcare. See, whenever you take the report or measurement, there should be accuracy should be there in taking the report. And that's what when you are running any KPI report, I usually tell you have to go and then depend only on the software report. Okay, nothing else you are maintaining as a lag report or something else you should not take, because your software will not change, right? The report will not change forever. It will be there. For example, after 2 years, someone is coming back and then verifying your data. There will not be any change. Okay, your software will talk for you. Okay, that's the way our data should be accuracy should be 100% on this our data. And the precision is nothing but, for example, amount of variation in the measurement system when it is repeated. See, for example, I'm running a report, okay, charge report for a 6 months. Okay, if I run the same report for 10 times also, the number should not differ, right? Why it is differing? For example, that's the reason we are asking our MIS team to take the report, charge report, once the month is completed. For example, he will run a report on 31st or 1st of every month, he will run a report on the charge side. And the payment, once you posted it, month is closed, he will run and then take the report, because on that particular scenario, when we posted the month, that is a report, right? And when we run a report every time, there should not be any deviation between these two reports. That's called your precision. Okay, these two is very, very important when you take any measurement. And measurement correlation. Okay, measurement system analysis compare values from different measurement systems. See, for example, I want to take one data. Okay, for example, I'm taking a charge report. Okay, the same your PMS system. I have 3 PMS system have the same practice. For example, Dr. A, they are using 3 PMS system using the same thing. If I take a 3 different report, the report will have a difference, right? So I'm not saying practically it is possible. I'm giving a rough example. Say, Dr. A, we are operating in ECW, we are operating in Allscript, and we are operating in CareCloud. Okay, the same system. I want you to take the report from 3. It will be differ, right? The 3 reports will not be similar because of your measurement system is differing. Okay, that's what for that scenario, we have to add some correlation to correct that difference. Okay, use to access the value we get from the CARG themselves. Okay, say for example, if you study the CARG methodology in the physics, okay, Vernier caliper and other things, whenever you take a measurement, they will add some calibration, right? The calibration amount they will add, plus or minus some amount they will give. So that indication, okay, it is not correct one. This will go 5% plus or minus. That's what we are also calculating when I was saying that GCR projected. This may go up 5% plus or minus. 95% we are claiming that as an accuracy. And comparing the 2 different measurement devices to bring the correlation. Correlation is nothing but, you know very well, measurement is going to bring some error. How we are going to correct the error? That's all, simple terms. But we don't have this problem in our healthcare. Okay, we will take all the reports from our system itself. Okay, precision methodology. So measurement here, we are going to see the detail. Okay, what all the difference will be there. Okay, one is repeatability and reproducibility. Okay, so repeatability variation. That means what? When you're taking the same measurement again, there is a difference is coming, right? See, for example, we will take your T-Works. Okay, I'm running a 90 plus report now, and then after 1 hour, there is a difference. Okay, repeatability variation is coming, right? It is a gauge for measuring the device itself. So we need to calibrate your system itself. There is a different report is coming. See, for example, in some other system, if you take any system, it will not immediately affect, right? For example, day, there is a day close will be there. For example, Allscript or your or the other system we have day close. Advanced MD, these are all some of the day close will be there. Okay, unless you close the day, your numbers will never change, or unless they run a backend data, your date will not close, right? We have a time till that time. So there won't be any variation. But here in the kind of therapy notes, okay, whatever you're posting, immediately it will reflect there. Okay, that's a repeatability variation is there. So this is a measurement device itself. We have to calibrate. So that's what we are we are taking the report and we are mentioning the time, right? At what time this report comes in. Okay, this difference is called equipment variation. Okay, I'm just referring to you in the different systems. Okay, for example, reproducibility variation, it's nothing but the operator. Okay, for example, I'm asking one operator to go and then check, okay, how many numbers of are now, how many products are produced by that particular machine on that particular time. Okay, this operator made his own time and then taking the report. Okay, for example, he's coming 5 minutes late and then he started taking the report, and that 5 minutes, the first priority operation will happen there. Something happening because of this operator, we'll call that as a reproducibility variation. Repeatability is related to the machine, reproducibility is related to the operator. Okay, these are all we need to take into consideration when you are taking any measurement. Okay, cause repeatability and reproducibility. Prepare. Okay, so that's what I refer to you, the vernier caliper, right? Whenever you're doing any device, you have to calibrate, you have to standardize. Okay, you have to finalize this, the error is going to happen, right? Then you are preparing it. That's what we discuss on the ThriveWorks, right? So we told them first we'll run a report and then send it to you. That's what we are going to measure hereafter. So we are both calibrating and then standardizing some measurement because of this machine variation, right? Equipment variation. We are coming back and then we are preparing ourselves and collect the resources. Okay, collect resources in the sense how we are going to take the measurement and collect the data. Okay, the collecting data should be the consistency should be there, and then calculate your repeatability and reproducibility. Okay, so this is a major thing when you're working with any machine. Okay, this repeatability and then reproducibility will be a major challenge. Okay, the precision to tolerance. Okay, PT ratio. So what is precision to tolerance? For example, there is a difference and there is a error is we are accompanying, right? That's what we discuss about this precision, right? Amount of variation measurement in the system is called precision. Okay, how much we can tolerance? Okay, precision to the total ratio, variance from the measurement divided by the total variation. So this is called precision to the total ratio, and precision to the tolerance ratio is tolerance to the process is equal to upper specification minus lower specification limit. This is called your tolerance in the process. Okay, for example, my upper specification limit, I can go up to, for example, I'm saying 98% is my top limit error and lower is 96%. So the 2% is my tolerance ratio. Okay, 2% I can do a error for my category. Okay, within that particular range, all my process should be set within 96 to 98%. Clear? Okay, right. So we'll go to the next one. Okay, the measurement, again, we are talking about the measurement. Okay, Bayes and then linear study is used to access the accuracy of the measurement system. Okay, there are two different studies are there. One is Bayes system, other one is linear study. Okay, what is the purpose of this? These two are aiming to get the accuracy of the measurement system. Okay, so how we can get the accurate data? Okay, choose a set of parts or variable of interest for the study. For example, I'm finalizing what all the things I'm going to measure. Okay, for example, we are giving the details to the quality team saying that you take my measurement on this. See, for example, I'm giving an instruction to them saying that you concentrate only on the client assistance category. So I'm defining them, right? I'm setting the parts of the variable of the interest. Okay, that's the way we can define the process. And parts should be minimize process variation. Okay, for example, whatever part you are selecting, that should have a very minimal process variation. Okay, so as I told you, this is not relevant to us, but in general, you have to select a minimal process variation as for your measurement. For example, your frequently your measurement is changing, we cannot come to a conclusion. So we should know what we are measuring. And parts that are created close together, okay, close together in the same production run. Same means For example, I'm running a machine. Okay, I'm producing some water bottle. Okay, you have to take all your measurement within the same production run. For example, one batch run. So when you want to say see the deviation or a variation, you have to take by batch wise, right? See, if you take any of the product, okay, for example, you are purchasing a curd, right? In the curd they will mention the batch type. So why they are mentioning the batch type? This is run in the particular batch. If any error or anything is quality is not good, they will go back and then check what is the batch, why it is happening. So usually the production will be done by the batch wise, right? This is a batch run. The same way what we are doing for a charge entry or a payment posting, we are creating a batch and then we are running it. So for example, if I identify there is a lot of variation on one particular batch, then I have to go back and then check the complete batch which is not good, right? The same way the choose operator. And then for example, I am taking one particular guy, ask him to run a report. Okay, and we have to select some experienced folks who can run a correct number, otherwise it will deviate. Okay, and we have to train the operator how to take a measurement. That is also very important when you are getting any measurements. Okay, monitor the study and then record the measurement. Okay, so we will see what they are monitoring, what they recorded, and how it is recording the system, and then how they are studying the reports and calculating the bias. Okay, average measurement minutes, the reference to the value. What do you mean by bias here? Okay, see, for example, I am allowing 3 operator to take a report. Okay, each one will have a different data which will not similar, right? There will be a lot of variation in the measurement. So now I have to calculate my bias. So how to calculate my bias? Summing up all the individual reading and then divided by n. See, as I told you, there are 3 operators are 3 people are running my reading, and what I'll do, I'll add all and then divide by 3 to make that as a standard one or average one. That's what the bias. We are avoiding the bias. For example, if I didn't do, I am taking only one guy's report, that is not correct. That will go to the bias method. So we are calculating that and then avoiding the individual preferences or individual references we are avoiding by doing this bias method. So then we then subtract t, which is a value of the standard or the reference. Okay, we'll calculate this and then divide by the t, which is a value of standard or a reference. This is nothing but, for example, as a vernier caliper, as I told you, there is a one standard error they are mentioning, right? First I'll do bias within my operator, and then I'll take the number again, I'll bias it with or subtract with my reference or a standard one. So then my measurement will be clean and the perfect. Then I'll use that measurement for my calculation. Got it? So taking measurement is a very big challenge in all other industry except us. Okay. Okay, again, step in measuring the linearity. Okay, we talked about bias here. We are going to talk about the linearity here. Okay, so in the linearity measurement, what we need to do, you have to choose the part or the variable. Okay, which part I'm going to select or which variable I'm going to measure, and you finalize which operator is going to do and monitor and then record what they are doing and then perform the linear regression. Linear regression we are going to cover in future. In that linear regression, we'll identify what is the linearity, how we can avoid the difference. Okay, percent agreed analysis. Okay, this one thing, before we start taking any measurement, we have to come to an agreement with the what is the error is going to happen and how we are going to attribute it. See, for example, here, okay, good for continuous data. Which one? This linearity, it is good for your continuous data. What is continuous data? Which is a numbers, right? Which can be divided and then we can measure it. These kind of data, linearity will be better. And attributes data, percent agreement, it is needed. What do you mean by percent agreement? That's what we come to a conclusion, right? See, for example, I am going to measure what is red, blue, and then green. Or we are going to calculate how many pass and fail. Okay, as we know that it is a, what data it is? Pass, fail, and all. Discrete or continuous?
Discrete.
Discrete, right? We cannot measure that. So what we are going to do is we are assigning the number, right? For example, we will assign that to a number. If it is pass 1, fail, it is 0. Like that we have to give, and then we have to come with the percent agreement method or scale of 1 to 5. See, for example, that's what we are using, right, to give a scorecard to our people, right? We are waiting there. 1 is a poor, and 5 is a extraordinary. Like that, we'll give a weightage, and then we are bringing that into a agreed value on the percentage agreed analysis. Okay, linearity is nothing but it's a straightforward. We are taking the number and then choosing the operator, monitor and record. Coming to the percent agreement method, it is attribute data. We are going to come to an agreement. We are going to give the scale of 1 to 5 or whatever the measurement, and we are coming back to the measurement category. Okay, any doubt here in this chapter? It's talk about the measurement. Okay, how we have to take the measurements. Okay, I don't think so. We need to break our head too much on the measurement, because it's more or less it's not applicable to us. Right, performance and then process capability measurement. This is a very big chapter, right? We discussed already. We discussed one time. Okay, component of the process capability. Okay, so when you are going to define your process capability, you should know what is your specification limit. Okay, customer expectation or a business design, this we already covered, right? Specifications that you should know what is your specification limit. Say for example, I am taking a FTE model on the charge entry. So 120 is a specification limit. Okay, that is the customer expectation. Okay, and if it is a payment posting, we know, right, 350 for EOB and then 1000 for EFT. That is our specification limit. What is process spread? Extent of the process variation. Okay, for example, 120 is the expectation. My process spread, it is going from 70 to 150. That is your process spread, right? And process limit. Okay, natural process variation and then determined by the process itself. Okay, process where it will limit itself. Okay, that is the process limit. Okay, and coming to measure variability, how we are going to measure here is predictive measurement in the process performance. Okay, see, based on the data what we have, we are going to do a predictive measurement and then see that how your process is performing, whether it is going to see any major changes or challenges. Okay, useful of designing, evaluating and optimizing the performance. It will be helpful to reduce your variation. Okay, and measuring the process performance. Okay, there's a MPK, CPK. Process performance is a count defect and an outcome measure. Okay, we are going to see that in a detail here. Okay, this is a process capability study. Okay, there are multiple methods. They are checking the process capability studies. Okay, this is the first one, is a 5 key step. Determine the specification. As we discussed, we know what is the specification. Okay, 120 is my specification, and then process capability study we can do and verify the assumption. Okay, to test the data is stable and the normal. See, for example, if a client is giving me a specification of 120 charge, okay, is it possible, right? But that we need to do. We'll do a time study to confirm it, whether it is doable or non-doable, because sometimes client will come back, say that we have to do 260 charges, which is not at all possible, right? We are doing the test and then we are seeing that is it a stable number, are able to achieve it, is it a normal expectation, or it is a one of the noise point. One time we are getting it, other time we are not able to get it. And second thing is gather the data. For example, if I want to do the time study, what I'll do, I'll put to 5 people and then take the representation sample by the 5 people and calculating the capability. Okay, determine the process capability and then the sigma level we are going to calculate. And based on the process is capable, we will make the recommendation. Okay, once we identify the process stable, and we will give a recommendation to them. Okay, we will go and then fix that as our process capability. Like that, we will fix it. And verifying the stability of the process. So for example, now I did my time study and then I confirmed that 120 I can do. That's what my process capability we are declaring. Okay, how we need to verify it is whether it is stability of the process or it is differing. Okay, the determining the stability of the process, stable fit in the normal distribution over time. So for example, I am running a 3 months production sample for a charge entry. So the individual user production range should be 120 always, right? Or with the minimum deviation. Then we know that the stability of the process is achieved. So to find this, we are having a 2 chart. One is X bar chart and then R bar chart. There's nothing but what we are using for the denial, right? We are using the SPC chart. Okay, there's a type of SPC chart. When there is a 2 to 9 subgroup, we will use X bar. When the ranges of the subgroup, for example, sample are collected at the each interval. There's no multiple subgroup. It's a one subgroup Within the subgroup, there will be a range. For that, we are using the R charts. Okay, and verifying the normality assumption. Okay, for example, bell-shaped curve, it is a single peak, which is a unimodel. Okay, for example, this is the one, okay, where we will go and then plot all this variation here. Okay, this is called your unimodel. The parameter mu, which is a mean, and sigma is a variation. Okay, and symmetrical on the both side around the mean, which will give a normal distribution. Okay, the bell curve distribution. 2/3 of the data, 68% of data plus and plus or minus one standard deviation either side of the mean. Okay, these are all some of the differentiation for the normality assumption we will cover in detail in coming slides. Okay, histogram we already covered, right? Normal probability plot, this is a normal probability plot. Okay, whatever the, for example, you're plotting your production for one single user for a month. Okay, and it is quietly increasing, then your plot will look like this. Okay, the fat pencil chart, the same plot, when you put it in different formats, say for example, the dotted lines are coming like this, we'll call this as a fat pencil test. Okay, these are all the name given based on the structure what we are going to get it after this particular plotting of the data. Okay, any question?
No. No.
Okay, we'll move on. Okay, this is a major challenge. Okay, here we are going to calculate our process capability. This we already covered one time. Okay, based on the process capability, see for example, if it is 3 sigma, your number should be 1. If it is 4 sigma, it is 1.33. If it is 5 sigma, 1.67. It is 6 sigma, it is 2. So how to calculate? This is a formula. UCL is not a UCL actually here. Upper limit and the lower limit divided by 6 sigma. So here the CPK, right? CPK is nothing but what is your process capability. So there's an upper limit and the lower limit. One is upper control minus mean divided by 3 sigma. The reverse is mean minus lower control divided by 3 sigma. And then we are going to take the min of CPU and then CPL within this 2 number, which is a minimum one. That is your CPK, right? So we'll see, I have some table here. We will go through that in depth. Okay. So I had taken some of the projects to explain you what we are doing here. See, for example, on the day also we did the same. Okay, so we are going by the production. We are taking the charge entry as a production measure. Charge entry production is a measure, and then we are calculating for a complete month. Okay, so this is a charge entry number. So what we are doing here is we are taking an average of this particular number. This is your average. And we are calculating the standard deviation for this particular range, and our average upper limit is, if you take max of this is the upper limit, and if you take the lower control limit is a minimum, we are taking this. Okay, this is not a LCL, this is a lower control limit. So based on that, we are going to calculate the CP. Okay, what is the formula for CP? It is upper control limit minus lower control divided by 6 sigma. So this gives upper control minus lower control, which is 120 minus 70 divided by 6 into your standard deviation. Okay, if you calculate, your number is 0.58. So 0.58 is coming in which category? 3, 4, 5, 6. In which category it is coming? Yara bol solunga ba?
3 sigma.
Adappavi. One is 3 sigma. Are we getting 1?
0.58.
0.58, right? It's not even 1. So you are at 2 sigma level. Okay. Whenever your sigma level is less than 2, we won't consider that as a standard practice. Okay, that one. The same thing we did here. Okay, I did one more round and make some better number. Okay, your average I calculated that as 120. Okay, so in this scenario also it's coming 0.64. Okay, the same calculation. Okay, now we try to do some more modification here, and then we brought some other methodology. See, for example, we'll go to this particular 3 table. Okay, I'll go from AF here. We'll take this table. See, what we are saying here is 120 is my average, what is expected by the client, right, as a production number. Okay, and what is my upper control limit? A person can do 130 for me, and a person can do 110 for me as a lower control limit. Okay, this two I am taking as my upper control and the lower control limits. Okay, and we are seeing that there is a 2.5 is a variation, standard deviation is coming between this particular process. This is a 1 month variation. Okay, the same way I'm going to calculate my CP. Okay, CP is 130 minus 120 and 6 sigma is 6 into 2.5. If you calculate in this way, my number is coming at 1.33. That means what? Your variation should not be more. See, it's the same person, right? It's not a multiple people. There's only one guy. Why he is giving a lot of variation in his production? So that we need to stabilize and make sure that what is the client expectation and what is the upper limit and what is the lower limit, and reduce your 6 sigma or deviations. Okay, if you calculate 1.33 here, what is our upper control limit? 1.33, we are fall under 4 sigma level. Okay, if your variation is only 2.5%, then you are at 4 sigma level. Okay, and I'll go to the same one. If your standard sigma deviation is 2, then you are at 1.66. See, the same thing I did here, and then your standard deviation is 2, then you are reaching at 1.66, which is equivalent to your 5 sigma level. Okay, and then if you come to this one, okay, where your standard deviation is 1.5, where your UCL and LCL is 130 and 120, here we are getting at 2.2, right, which is equivalent to, see here, when you are touching 2, then it will become a 6 sigma. See, by doing this capability analysis, process capability, what you are trying to do here is you have to make sure that your process deviation should be controlled. Okay, if you are able to control your process deviation, then your process will be stabilized quicker. Okay, for example, that's what I try to compare with this particular chart. See here, your flow is this. Okay, from 120, that guy is doing lot of different production in a different way as per our sample, right? If you plot that into a picture, see here, this is a variation, right? There is no standard area where he is doing it, right? There is a lot of variation in the production. So that variation you have to remove if you want to make your process into a next level, right? So see here, the same way we will give add one more table here. What is the average? Okay, now we'll take this into the same picture. Now you can understand what is your variability. See, this is what your variable, right? Your 120, how he performed. See, whenever you are getting a lot of deviation, your process is not stabilized, right? And you cannot commit your process saying that I will give 120. I have 3 people. You cannot strongly commit to the management saying that I will give you 360 because your process is not capable, right? This will give an indication your process is capable or not capable. This is what we need to identify, and with your deviation should be controlled. That's what we are trying to come here. Okay, for example, what we did here is whenever your deviation is getting reduced, standard deviation, see 2.5 you are at 4 sigma. When it is reducing to 2, you are at 5 sigma. When it is still reducing, you are able to reach at 6 sigma level. So if you want to stabilize your CP, you have to concentrate on the lesser deviation. Okay, now we'll come to that CPK, okay, which is upper limit and the lower limit. The same thing which we are doing here. Okay, the formula what we are seeing here for this is, see, UCL upper limit minus mean divided by 3 sigma. Okay, that is equal to your upper limit minus your average divided by 3 sigma level. Now we are getting at 1.3. Okay, the same thing what we are doing here is a lower control limit, which is LCL minus your average and divided by the 3 sigma, which is 1.33. You have to take the min of it, which is minimum. Both are same number. So 1.33 is my process capability. Okay, CPK is my 1.33 here. The same way here 1.6, and here it is 1.2. But many of the time it will differ. Okay, it will not be the same number. Since we manipulated the number, it is showing same. Otherwise, the CPU and CPL will differ. Okay, any question here? This is very important to stabilize your process. If, for example, as a manager, you want to take 1 week leave. See, if you calculate your process capability, okay, CP and CPK, if CPK is coming under 1.2, okay, you can take 1 week leave confidently. Okay, if it is 0.58, you cannot take leave.
Got it.
Okay. So who want to leave, you have to come with CPK hereafter.
With scores also, right?
CPK, yeah, CP and CPK score for your production level.
Sir, 9 sigma la அன்னைக்கு சொன்னீங்க 6 sigma-க்கு இப்படி இருந்ததுன்னா அப்ப 9 sigma-க்குலாம் எவ்வளவு இருக்கும்?
So the same thing, right? There won't be any variation at all. The same thing you take here. Okay, so what we are saying here is 2 is your 6 sigma level, right? You take 0.5 variation. Okay, 6. This will be come around your 9 or 10 sigma level. It will come. Even if you keep 1, see here, 3.3, which is 8 sigma level. Oh. The variation is very important. Okay, say for example, if you ask your team to run, they should run in the straight line. That's the way your process should go. That deviation is a problem, right? Where we are struggling. That's what we are trying to explain here. Any other question here? So deviation is our major challenge for any of the process. Okay, right. We'll move on.
டீவியேஷனே இல்லாம போச்சுன்னா என்ன லெவல்ல வரும்?
டீவியேஷனே இல்லாம போச்சுன்னா பயங்கரமா இருக்கும். அது மாதிரி ஒரு ப்ராசஸ் இனிமே தான் கண்டுபிடிக்கணும் உள்ள.
ஓகே.
Deviation illama varum, process varum. Epo varumna, for example, if you are taking that your aircraft and other thing, right? So that and all, there won't be any deviation, right? They will start and then they will end. See, every trip will be calculated as a 6 sigma level, right? They will start and then they will landing the flight. That's completed. Okay, adallam pathina it will be 9 sigma level and range la irukum. There won't be any deviation. Okay, if any deviation, they will ask you to return back. And then there will be a huge penalty for the pilots and other people. Deviation irukadanga. There will be a straight line. Okay, you put a straight line, you have to go in the straight line. நான் வந்து ஒரு ஃப்ளைட் பைலட்ல உட்காந்துட்டு நான் வந்து ஏன் ஸ்ட்ரெயிட் லைன்ல போனோம், நான் வந்து இப்படி ஒரு டர்ன் பண்ணி போனா என்னன்னு, இஃப் யூ டர்ன் இட், that will be a calculated as a deviation, right? That is a major challenge. When the investments are going high and high, you will have these kind of deviation restrictions will be there. For example, the diamond they are producing, right? Diamond and all, the scratching, okay, how it need to be done, how it need to be polished, it will be the highest level of standard deviation, because whatever you are doing a waste, it's making a huge loss for the process. நமக்கு இன்னைக்கு பண்ணலாம் நாளைக்கு பண்ணிக்கலாம்ன்றனால தான் நம்ம இவ்வளோ லெத்தாலஜிக்கா we are leaving the process. Otherwise, if you streamline it, see இப்போ என்ன ப்ராப்ளம்னா, if you streamline everything under your process control, say that's a way. Process control one vanduchina, you don't need multiple layer of managements, right? Team leader, team coach, and then manager, adukku mela overall ivala theyappadadu. You plug and play. Okay, if you plug it, it will automatically go. That's what we are trying to do. If you see some of the projects, okay, it will go smoothly without any problem, right? Say for example, few account, okay, there won't be any issue, automatically it will go. But here or there also, if you see sometime it will go up and down. Okay, that means still we need to streamline that particular process, right? The standard deviation and other thing, we have to straighten up the process. See, multiple process, for example, charge entry, payment posting, நிறைய process எல்லாமே நீங்க வந்து, if you process everything under your process capability, then there won't be any deviation. யாருமே உங்களை ஐடென்டிஃபை பண்ண முடியாது. Okay, it will go smoothly without any intervention. That's the way we have to run this.